we're learning about that vertex form of quadratic. So here is the vertex form of the quadratic. I want to remind you that the parent function is y equals x squared, or f of x equals x squared. And h and k are the vertex. Okay, so if they give you values for h and k, you now have the vertex of the quadratic. Okay, we'll be talking about these two flaps later. Okay, so if we're looking at changing the sign of A, the transformation that's happening there is a reflection. So you might see that word reflect. Okay, when we're talking about a reflection, if we have a positive A, we don't reflect, it just opens upward. Okay, that means it has a minimum. That means I'm going to have y is greater than or equal to k for my range. And that it's going to open upward. Okay. If we have a negative a, then your parabola will have a maximum value, meaning that my range will have y is less than or equal to my value for k, and this one opens downward. And that's all just from the sign of A. If A is positive or A is negative. In the parent function, A is a positive 1. When we're changing the value of A, that's like calling it a dilation. You are always looking at talking about the scale factor. Did it get bigger or smaller? In this one, we're talking about whether or not it's increasing or decreasing. Right? And when we're talking about this value of A, we're going to ignore the sign, meaning that if it's opening upward or downward is not what we're concentrating on, but we are concentrating on the absolute value of A. So if A is greater than 1, what we end up seeing is something that is skinnier or narrower than the parent function. You might see it called a vertical stretch. And imagine if your parent function was a rubber band and we stretch it going up and down. Okay, so vertical stretch. If we're looking at A being less than 1, the quadratic that we're looking at will be wider than the parent function, or you might see that called a vertical compression. And what we're saying there is we've taken our parent function and we're smushing it. Okay, so that's what they're doing. They're smushing the parent function. Okay, and in both of these cases, you would see by a scale factor of whatever that A value is, because that's what's being multiplied to the x squared value. When we're talking about changing the values of h and k, the related term from translation, that slide. So changing the value of h, remember h is which part of the vertex? It's the x part. So x-axis goes left and right. So if we have x minus h squared is in the function, what we're really saying is it moving right. And then if it says plus h is a negative value, so it's moving left. This is our horizontal shift, how it changes from left to right. So they might say it shifts left, it shifts right. It's a horizontal shift of 3 units. Okay. When we're changing the value of k, since our vertex form has plus k, if it's moving plus k, that's moving up because k is a positive value. Negative k, it's moving down. So this is when they're talking about the vertical shift. All right, so back at the top, we can compare these examples to the parent function, and you negative. So if I've changed the sign of A, I'm dealing with a reflection. So you might say, okay, this opens downward, or you might use your terms of it's a reflection over the x-axis, and it's always going to be over the x-axis for now. 8/5. 8/5 is greater than 1. So that means we change the value of A. 8/5 is greater than 1. So we could say narrower, or we could say vertical stretch. We'll just use our new term of vertical stretch. And you might see this by scale factor of 8/5. And then the next one says +3. That's changing my value of h. Since it says plus, that means I'm going left. So I can say shift left, and that's a 3, so 3 units. So comparing to the parent function, we don't have a reflection because the sign of A is not changed. We do have a dilation. 8.3 is greater than 1, so we would say vertical stretch, or you could say narrower. As long as you know that those terms are interchangeable, you should be fine. By a scale factor, and I'm just going to abbreviate and say SF for scale factor, of 8.3. It says minus 2.5, so that is a change in H. Minus means it's moving right. Shift right, 2.5 units. Then they have plus and negative, which we don't see that very often because you would normally simplify to just saying minus 2.5. Here we're saying, okay, minus 2.5, it's going to shift down 2.5 units. Question would be, just where is the vertex on this transformation? Well, remember that h is my value of the x coordinate, so 2.5, and k is my value of the y coordinate, so negative 2.5. Okay. So something that you will probably be expected to do is to compare quadratic functions to each other. So from one function to another, where neither of them are the parent function. So here we have to compare them to each other, saying, okay, if I'm looking here, what's the difference? Well, this value of A went from narrower than the parent function to wider. A became smaller. So if that's the case, we would say h of x is wider than g of x. Oops, we got a typo. This should probably say plus, or it should not have any sign whatsoever. So if we go from negative 2x squared to positive 2x squared, we see a change in the sign of A, meaning that we have a reflection. You can compare your vertex. This vertex would be found at 1, 0. This vertex would be found at negative 3, 0. If I were to graph that, and we can just sketch it, we have one right here and one over here. I don't even have to look at the whole quadratic function to say, oh, h of x is 4 units left of g of x. Okay. If we look here, my vertex would be at 0, 8, and this vertex is at 0, negative 10. So if you think about what the graph would look like, it went from all the way up at 8 to all the way down to negative 10. So we're looking at going down 18 units. You can do that with one piece, like looking just at A or just comparing the vertex, but you could also say, okay, how does this compare to this? When you would go A, okay, well, this one has an A value of 1, this one has 1/2. So going from an A value of 1 to 1/2 means that I'm dealing with something that is wider. This one had an H value of -2, and it went to +1, because remember H is kind of the opposite. Okay, so we're looking at just at the H value, and H is the X coordinate. So then I can say, okay, it went 3 units right. Looking at the K value, well, I was at -1, and then we went to -5. Okay, so does that go up or down? Well, it goes down 4 units. So take it in chunks. Don't try and look at it all at once. You look at the A value, the H value, the K value. A is still 1 here, and now it went to a 2. So now we know that it's narrower, or a vertical stretch. The H value was -2, then it's -10. So that means, think about how a number line goes on the x-axis. It means it's starting here, and then it went over to -10, so it went 8 units left. How did I get that number 8? Okay, well, that's the difference between -2 and -8. My K value went from -1 all the way down to -10. It went 9 units down.